the history of data centres. I'm sure that as experts in the field, you're all now aware that 55% of the global population are connected, and data traffic accounts for at least 4.2 trillion gigabytes a year. Also, that there are over 7 million data centres around the world. Nobody knows exactly how many, but they range in size from cupboards with one rack to hyperscalers. And there's massive, massive economic investment in the sector. But to date, the focus on sustainability or within the sector has been 24/7 operation and energy efficiency. In 2018, it was predicted that by 2025 in the EU, the sector would expand by 300%, and by 2030, the sector would expand by 500% globally. And that's partly because of the introduction of things like Industry 4.0 and cyber physical systems. I mean, everything is becoming more and more connected. And of course, we need a growing data center industry to cope with all the data that is and will be generated. So I'm giving you a little bit of context because I think we forget how fast and how enormously the sector has developed, particularly since the introduction of the World Wide Web in 1989. And it means that the development of hardware has really been in a very linear fashion. We haven't had time to stop and think about anything other than taking resources, making stuff, using it without any consideration of what happens to it at end of life. So the whole sector has developed along a linear model of consumption. But we can't afford to do that anymore. I think it's evident when you consider the amount of e-waste that's generated globally. At the moment, it's approximately 50 million tonnes, equivalent to about 6 kilos per person. And if we carry on working in the way that we're working, by 2050, we will generate 120 million tonnes of e-waste a year. Now, that doesn't mean that all of it is dumped in landfill and so forth, but at end of life at the moment, less than 20% of EEE, electrical and electronic equipment, is formally collected and recycled. And an awful lot of stuff, we just don't know what happens to it. Some is sold on informal secondary markets, some is shipped overseas and sort of vanishes, but we definitely know that a lot is shredded and ends up in holes in the ground. And we can't keep behaving like this because at the moment, at least 20 critical raw materials, which are materials of high economic and technical significance in the EU, at least 20 of those are included in electrical and electronic equipment, and specifically data center equipment. And the majority of that stuff ends up being dumped at end of life. So we're going to have supply chain problems before too long. So it's evident that we need to shift from a linear economy, take, make, use, dispose, to a more circular economy where we begin to mimic natural systems. So just as leaves fall off deciduous trees in the autumn and become food for the next generation of products, what we need to do is ensure that we return materials to a system for as long and keep them in use for as long as it's technically and economically feasible. Now, a lot of people think that this circular economy is just about recycling, but it's not. It's about much more. And if we look at the waste management hierarchy, we can see at the moment we are sort of mimicking, or our approach is mimicking the triangle on the left. We need to shift so that our whole economy and circularity mimics the triangle on the right. The waste hierarchy is inverted so that the least amount of stuff is disposed of as waste. We increase recycling, certainly increase reuse, and we also, and this is a kind of a contradiction, we increase reduction. By that I mean we consider using fewer materials, making products that are a lot more resource efficient. And the technical term is dematerialization. So whatever we produce is much more resource efficient. Now, the Circular Economy Action Plan was put into circulation by the EU in 2020, and that's followed by the UK Circular Economy Package. But one of the focuses that we should note here, there are certain key areas that are absolutely ripe for developing a circular economy because of the inherent value, etc. And this includes electronics, ICT, and batteries. So therefore, as an industry, we really need to switch to a circular approach. And if you look at the key recommendations, at the moment these are guidelines, although they gradually will become directives or whatever, 24 out of 35 key actions in the circular economy plan directly relate to the data center industry. So if you can get ahead of the game as an industry, then start developing good practice, you're going to have business advantage. Since 2018, I've been leading a project called SOOCon23, which preempted the Circular Economy Action Plan. It's an acronym for a circular economy for the data center industry. And it's an interdisciplinary project that uses whole life thinking, and it brings together representatives from all the different subsectors in the industry. And it directly and coincidentally now supports the EU Circular Economy Action Plan. So we have 24 and associate partners in the UK, France, Netherlands, Germany, Belgium, Luxembourg, and Ireland. And some are full partners, some are associate partners. But the fantastic thing about the partnership is that it includes representatives from most of the DCI subsectors. And also, we work hand in hand with industry. So we're able to generate innovative approaches to challenges, but being supported by industry. So it's an ideal combination. And one of the unique factors in the project is that we use primary source data. Most environmental and other assessment libraries or processes rely on either secondary source data or assumptions. So 10 years ago, a researcher might have done some work that has subsequently been repeated and scaled up and scaled down, And so a lot of the data sets aren't as accurate as they should be. And that, combined with the fact that obviously data center equipment and technology has moved on, mean that, if you're doing life cycle assessment modeling, for example, the results are inaccurate. So we literally roll our sleeves up, disassemble products, make inventories of all the materials, the manufacturing processes, send certain products to France to our fantastic R&D recycling partners, who then, through pyrolytic and chemical processes, are able to identify exactly what materials are in data center equipment, because the OEMs, etc. I bet some of them don't even know, because they subcontract and re-subcontract, but they will not give information about the materials that are in components. So we have to reverse engineer everything. All of the data that we've collected is now filtering or being used to support development of our Circular Data Center Compass, the CDCC, which is a key project output. But in addition to looking at environmental impact, we're taking a truly sustainable approach and considering social and economic impacts as well. There's no point in designing the most environmentally friendly product if it's made by, let's say, slave labor, etc., and is so expensive that nobody can buy it. So we need that good triple bottom line approach. And we use indicators to show environmental impact, the cost or life cycle costing, economic impact, and social impact as well. And we've also included a criticality indicator, and this is something that is coming more and more to the forefront. It's becoming more and more important, not just for the data center industry. But we know, and if you think about some of the supply chain problems that we experienced as a result of COVID and now things like the Ukraine war, there are genuine threats to supply chain. So we are showing the criticality risk of materials in different products, so that as a user you can be aware of that. Now, the other thing that we do is we consider whole life cycle, not just carbon. Carbon is a useful metric. It's indicative at best. Sometimes it can be a bit misleading. But if you're just looking at carbon and carbon equivalents, you're failing to consider loads of other impacts that are equally important. Think about water in the DCI, for example. Think about critical raw materials or stuff that is mined using very toxic processes. That is completely excluded from carbon assessment, but it's really, really important. So our life cycle assessment criteria for environmental impact, you can see how many different criteria are there. They include things like fossil fuel depletion, obviously, but also radiation, human toxicity, etc., etc. And this is a really, really important slide, perhaps one of the most important pieces of work that we've produced from the project, along with the compass. This is an indicator. It shows how important it is to consider things in addition to carbon. So on the left of the screen, you have two sets of bars from two different servers. And if you're just looking at carbon, you would think that the operational impact accounts for 80 to 85% of overall life impact, and embodied impact is therefore 15 to 20%. But then if we look at a full LCA that includes thousands of different inputs and outputs, we see the ratio shift. And in a slightly older server, and don't forget these are sort of, samples, it's not absolutely definitive. This is indicative research at the minute. The older server, the ratio shifts. So we have 70 to 30 operational to embodied impact. But in a new, very or comparatively energy efficient server, the operational impact and the embodied impact are about 50-50, which, this is what, we've got a big problem in the data center industry that has really been ignored, the impact of hardware. So our social life cycle assessment, we use UN guidelines, life cycle costing, a very bog standard formula here. And then I mentioned criticality. Again, for this modelling, the results are presented as either longer-term or short-term impacts. And you can see here we've got dysprosium, gold, strontium are the most critical metals in the short term, things that we need to be concerned about, things that we really do need to recover. So the compass tool, and if anybody's interested, I have some lovely cards here so you can log on and have a look. The compass tool was developed with a really big team of life cycle assessment, environmental refurbishment, recycling, etc. experts. It has 3 stages. You can either compare current server that you may want to upgrade by swapping components. So that compares a combination of embodied impact and operational energy, etc. There's an end of life. Do you want to recycle at end of life, for example? And then the key thing, we've got a design evaluator as well. And the results are all presented. They're not aggregated, so you as a procurement person or whoever can make an informed decision based on your company's priorities. Is it economic factors, environmental, social impact? And you can also be aware of the criticality. And then recycling options, we have the standard recycling process, which involves reclamation of ferrous materials, aluminium, copper, and a bit of gold. But we, in the SODASI recycling process, reclaim more critical raw materials. So again, we present the results so that you as an end user, when you're retiring a product, you can decide whether you're going to go for the business as usual recycling option or go for a more environmentally friendly SODASI option. Oh yeah, and we also include landfilling, not because we advocate that, but because it's a really good benchmark, and you can see the advantages of either refurbishing, recycling your product at end of life. And then finally, we have design. Now, thinking about recycling and refurbishment or second life of products, that's all really reactive. It's dealing with the stuff that's already in circulation. And we need to look beyond that. And this is why whole life thinking is so important. We need to think about designing stuff that facilitates recycling and refurbishment. And refurbishment is absolutely critical. Extending product life is critical at the moment and will be for the foreseeable future in terms of resource efficiency. But also it's critical because we don't have a recycling infrastructure to produce everything that is coming into the system for recycling. So 80% approximately of a product's environmental impact is determined during the design phase. The design phase is the proactive phase. And we have an evaluator in the tool here that enables designers to see how circular or otherwise their decisions are as they go along. And the criteria, everything in the tool is really easy to use. It's all through drop-down menu, etc. And as you progress through the tool, you'll see the spider's web will fill, hopefully, and you get an indicator at the bottom showing you how circular or otherwise your design proposal is. And the final slide, almost. So we use the tool to design our beautiful circular server, and it's really, it embodies the criteria that I explained in the waste hierarchy, in as much as it's much more resource efficient. It's a modular platform, so components can be easily swapped in and out, ideally from generation to generation. It's also got a very consistent component configuration, which we found through research that even, same manufacturer, one generational model to another, you'll find slightly different components, so nothing can be swapped and intermixed. It facilitates easy and rapid disassembly. We've reduced the overall mass by 33%. We have reduced and rationalised the number of components by over 50%, and reduced use of plastics by 90%. And that is really important because at the moment, in electrical and electronic equipment, most plastics are covered with fire retardants like antimony, which means you can't recycle them. So thinking about the future, the next generation of products, you replace plastic components with metal components where possible to facilitate recycling. And that, last slide. So circular economy, it's more than about just recycling. We need to consider all life cycle stages simultaneously and to understand the interrelationship between them. The current focus in the DCI is energy efficiency and carbon, but we need to move beyond that if we're genuinely going to become circular and develop solutions with lowest overall impact and regenerative solutions. We've considered reactive issues like end of life and refurbishment, but we need to be proactive and design products that are fit for the circular economy. And then the last thing, as I mentioned, we've got some cards here. Our compass is open access, which is good to present at an open conference here. It's free to use and it supports informed decision making. And we're hoping that our circular server, what we have learned, if we can't put the prototype into production, which is proving rather challenging, certainly the learning and guidelines will be published and be publicly available to everyone. And as Albert said, we can't solve problems by using the same kind of thinking we used when we created them. And that's it. Thank you very much.